Okay. So the definition is a number of the form A I B, where A and B are real numbers. So any number of the form A plus IB, where A and B both belongs to the real numbers. So such numbers are known as complex number. The A is known as the real part and B is known as the imaginary part. Like in the yesterday's class, we are covering the nature of the roots. Then there were two types of the real and the imaginary roots. So imaginary roots means whenever there is a negative number present in the square root. So let's say then if there is any number, so imaginary numbers are denoted by I, and there is a special number I square, and its value is -1. So imaginary numbers which doesn't exist in reality, they are denoted by small I, and its square is -1. But we know that when we do square either of the negative number or of the positive number, we get the positive number. So that is why these are the imaginary numbers. Such type of numbers doesn't exist. When we do the square of imaginary number, we are getting -1. So how to this was formed, the imaginary part is formed to solve such type of expression. Whenever there is a negative number in the square root. So how to solve that? So if let's say I'm taking very basic example, it is a negative 2 inside the square root. So I can write this as 2 into I square, because I square is -1, or you can also write is -2 into 1. So -1 is replaced by I square. So now if I have to solve this, so that will be root 2I, because this is a square term and it is inside the square root. So this square will be cancelled out. So to remove this negative sign from the square root, we use this symbol I imaginary, and I square is known as -1. So root 2I. So if any number is written like this, 2 plus I 3, or 2 plus root 2I. So such numbers are known as the complex numbers. In complex numbers, there will be two parts of the number, a real and imaginary part. So whenever I is written with any part, so that part is imaginary parts and the other one is real part. So like in these two examples, 2 is the real part and I3 or root 2I, the second part of this expression is imaginary part. So please note down the definition. Then we'll do a basic example or a little bit different.
Yeah.
So the complex numbers applications, like it is used in the quadratic equations also. So I'm just taking an example that if it is written as solve the equation x square minus 6x plus 58 is equals to 0. So let's say I'm using the quadratic formula since it is a quadratic equation to solve this equation. So the formula is x is equals to minus b plus minus square root of b square minus 4ac over 2a. So a is the coefficient of x square, that is 1, b is negative 6, and c is the constant term, that is 58. So now I am substituting these values in the formula. So x is equals to minus b. So minus and b is negative 6. So there will be two negative signs which will make a positive. So minus b will be positive 6 plus minus b square means negative 6 square minus 4 into 1. A is 1 and C is 58 over 2A. A is 1. So x is equals to 6 plus minus a negative 6 square will be 36 minus, and I think that will be 232 for it's a 32. So, yes, over 2. So now I have to subtract this, so that will be x is equals to 6 plus minus. So we'll have the negative term in the square root since the greater number has a negative sign. So 36 minus 232, that will be negative 196 over 2. So how to solve whenever there is a negative term in the square root? See, if this is a question of the quadratic equation, then there is no need to solve it further because there is no real root exist. But in this question, it is written that you have to solve the equation, and it is a part of the complex number. So now you have to solve this. So as I told you that I can write this as 6 plus minus negative 1 into 196. It will not make any difference. It is same over 2. And I square is negative 1. So in place of negative 1, I can substitute I square. So x is equals to 6 plus minus I square into 196 over 2. So since we have a square root over this term, so this square will be cancelled out. 6 plus minus I, and 196 is the square of 14. So when you solve square root of 196, uh, you will get 14 over 2. So now in from the numerator, I am taking 2 as common because both terms are the factor of 2. So 2, 3 plus minus 7i over 2, this will be cancelled out. So our roots or the solution of this equation will be either 3 plus 7i or 3 minus 7. And both are, the answer is in the form of the complex number because this is the real part, this is the imaginary part. This is the real part and this is the imaginary part. Have you written this?
Yes, I have.
Okay. So now, the first type of questions are based on whenever the two complex numbers are equal. So the condition is that two complex numbers, let's say the first one, so Z1 is equals to A plus IB, and the second is Z2. Let's denote C plus ID are equal. So two complex number will be equal if and only if their real parts is equal. That is, its real part is A and its real part is C, and imaginary part is also equal. So that is B is equals to D. Or if you want to write IB is equals to ID, then I will be cancelled out. So at the end we will have B is equals to D. So it means the real parts should be equal. Real and part and imaginary part both should be equal. Then the complex numbers, two complex numbers will be equal. So based on that, I'm writing a question which you have to solve. And let's say if 4x plus I is 3x minus y is equals to 3 plus I negative 6. So you have to find the value of x and y. So please try.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So have you got the answer for this question?
No. Not yet.
You can see that this is a complex number because it is written in the real and imaginary part. This is also a complex number and there is an equality sign between them. It means this is given that the both the complex numbers are equal and we have to find the value of x and y. So we just covered a condition that whenever the two complex number are equal, so the real part will be equal. So in this, the first complex number, the real part is 4x, and in the second complex number, the real part is 3. So the real part will be equal since both complex numbers are equal. So if I transpose this 4, so the value of x will be 3 over 4. So that is the value of x. Now we have to equate the imaginary parts also to get the value of y. So in the first complex number, the imaginary part is 3x minus y is equals to, in the second complex number, the imaginary part is negative 6. So now I have to substitute the value of x, which I have obtained from the equating the real part. So x is 3 over 4. So 3 into 3 over 4 minus y is equals to negative 6. So that will be 9 over 4 minus y is equals to negative 6, transposing this y on the right hand side and negative 6 on the left hand side. So this will become 9 over 4 plus 6 is equals to y. So I have to take the LCM. LCM will be 4. So 9 plus 24 is equals to y. So value of y will be 33 over 4. So whenever there is a equality sign, it between the two complex number, it means those complex numbers are equal. And what we have to do, we have to equate both real parts and imaginary parts separately. So by equating the real parts, I got the value of x, that is 3 over 4. And by equating the imaginary parts, I got the value of y, that is 33 over 4. Please have a look at this. And if you have any doubt or confusion, do let me know.
Very clear. Thank you.
Okay. Please note this down. Says addition of two complex numbers, or addition of complex numbers. So let's say same that the first complex number is this and the second complex number is this one. So if two complex numbers are given and we have to add both of them, z1 plus z2, consider this as a small z. I know it looks like capital Z. So z1 plus z2. So the addition of the two complex numbers, so how will we add? We just add the real part, that is a plus c, and imaginary parts together. So that's how we add the two complex numbers. Add real parts together and add imaginary parts together. So I'm writing a question for you. Based on this one, you have to tell me the answer. And that's correct. -4 plus 8i. That is the correct one. So the same process is followed for the um, difference. So if we have to find Z1 minus Z2, so that will be A minus C plus B minus D imaginary parts. But if it was written Z2 minus Z1, then it will become C minus A plus D minus B into imaginary parts. So it depends. Have you written lists?
Yes.
So yes. So next is the multiplication. Let's say there are two complex numbers. The first one is Z1 is equals to 3 plus I5 and Z2 is 2 plus I6. And we have to find Z1 into Z2. That is 3 plus 5 and 2 plus I6. So we'll follow the same process like we do in the algebra. Firstly, this 3 will be multiplied by 2, that is 6. And then 3 will be multiplied into 6i, that will become 18i. And I5 into 2, that will be 10i. And I5 into I6. So multiply the numbers 5 into 6, 30, and I into I, that will be I square. So plus 13 I square. So solving the like term 6 plus 18i plus 10i, that will be 28i plus 30i square. Now, since we know that the value of I square is -1, so we will replace this I square by -1. So 6 plus 28i minus 30, or you can say minus 24 plus 28i. So that will be the final outcome from this question. Note this down. I'm writing another question side
Okay.
for you. So you have to express minus 5i 1 over 8i and 8 plus I.
I'm getting a whole number.
Okay, what's your answer?
5/8.
Okay, so 5 over 8. So that's the real part. And if we are not getting imaginary part, so but we have to write this in a plus ib. So I can write 5 over 8 plus I, and in place of b I can write 0 because there is no imaginary part. So that will be 5 over 8 plus I into 0. Okay, the next is find the value of I raised to the power 6 into I raised to the power 8. Okay, let's see. So I raised to the power 6. I can write this as I square raised to the power 3 multiplied by I square, and this will be raised to the power 4. So I square is negative 1 raised to the power 3. I square negative 1 raised to the power 4. So minus 1 raised to the power 3, that will be negative 1. And we do when there is an even number in the power and there's a negative number, so it will always be a positive number. So minus 1 into positive 1, that will be negative. Or you can
Oh,
say that minus 1 raised to the power 4, that is minus 1 into minus 1 into minus 1 into minus 1. So this will minus minus plus 1 multiplied by minus minus plus 1. So that will be positive 1.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Please try solving this one. Okay, so I have solved this one. I can cross verify.
I think it's 76.
Which one?
I made a mistake in adding the eyes, but I got
Okay.
43.
Okay. So your real part was correct.
Yeah.
Okay. Yes. So try this one. You have to find the value of P and Q. Yes. Okay. I'm writing the first step. So P plus QI. So this will be in the multiplication. If I move this on the other side, so 3 plus 5I is equals to 1. So in the next step, you have to multiply these two complex numbers and you have to write in the simplest form, and then you have to compare because there is a equality sign between them. It means after multiplying these two, you will be getting a complex number, let's say Z1. And this is also a complex number because we can write this as 1 plus 0 into I. So Z1 is equals to Z2. So then you have to compare the real and the imaginary parts. So you will get the value of P and Q. Okay, Fahima, do you know how to solve the simultaneous equations?
Yeah.
Okay, so because in this question at the end there will be two linear equation in two variables, so you have to use either the substitution or the elimination method.
Okay. So you're saying I have to
Yes.
expand this.
Yes, you have to multiply that. So after multiplying, so P into 3, that will be 3P, and then 5I into P, so that will be 5EI plus 3QI plus 15QI square is equals to 1. So I square will be -1, so this will become 3P minus 15Q. And here in these two terms, I have I. So if I can take I as common, so that will be 5P plus 3Q is equals to 1. Or I can write 1 as 1 plus 0 into I. So now it is in the simplest form. There is no like terms which we can solve. So in the next step, you have to compare the real part and the imaginary parts. So on the left hand side, this is the real part because they are written with I. It means they are, this is the imaginary part. So the real part 3p minus 15q is equals to, on the right side we have real part this 1. So 3p minus 15q, that will be the first equation. Now comparing the imaginary parts on the left hand side, the imaginary part is 5p plus 3q, and there is no imaginary term on the right hand side, it is 0. So that will be the second equation. So I think you have to solve these two equations, and that will be your homework,
Mhm.
and you can find the value of p and q.
In the first step itself, when you expanded, where did you get 15qi squared?
This step.
Yes.
Okay. So so 3p plus 5pi plus 3qi, and the value of I square will be -1. So -1 when multiplied by 5q, so that will be -5q is equals to 1. So now we have to pick the real terms and the imaginary terms. Imaginary terms will be those terms in which I is written. So in these two terms, I is written. So I can take I as common in these two terms. So what I will have 5p plus 3q. So that will be the imaginary parts. And these two terms in which I, that is imaginary part, is not written, that will be the real part. So 3p minus 5q plus I is equals to this.
Thank you.
You're welcome.